Let's learn about the internal structure of the Earth. We can see the continuity from the early days of the formation of the Earth. As we try to look deep inside the Earth, the geologic component layers of the Earth, it took us years of scientific investigation and analysis of data to form an understanding about the interior of the Earth. The main reason for this is that the deepest mines we have dug do not go beyond a few kilometers under the surface, while the radius or the distance to the center of the Earth is over 6,000 kilometers. As you can see, the Earth's layer consists of crust, mantle, outer core, and inner core. Let's discuss about the depth of the crust, which is 0 to 100 kilometers, and the depth of the mantle from 100 kilometers to 2,900 kilometers, and the outer core depth from 2,900 kilometers to 5,100 kilometers, and the inner core depth goes from 5,100 kilometers to 6,378 kilometers. As you know, the Earth is made up of three main layers: crust, mantle, outer core, inner core. We live on the outer part of the Earth, which is called the crust. The crust mainly consists of various kinds of rocks. Mantle is a pliable layer over which the crust floats. Mantle consisted of chemicals called silicates. Core is subdivided into outer core and inner core. Outer core is composed of liquid metallic material like iron and nickel, and inner core is made up of liquid gold and iron. The crust forms 1% of the volume of the Earth, whereas mantle 16% and outer core, inner core 83%. The thickness of the crust is just about the thickness of the shell of an egg. If we assume that the size of the Earth is equal to the size of an egg. Interestingly, matters from deep inside the mantle shoots up through volcanoes and fissures on ocean floors and cools down to form the Earth's crust. In many regions, part of the Earth's crust enters into the mantle and once again becomes molten. This constant process of the formation and destruction of the crust explains the fact that our Earth is still very active. Let's learn about the movement of the Earth's crust. As you can see, the shape and position of the continent may seem fixed at the time scale of human experience. However, when you look at how old our Earth is, continents have moved, collided, merged, and then been torn apart again. Mountains have risen and been razed to the ground. Oceans have formed and dried up. Valleys have been carved, and so on, during the course of Earth's eventful history. Let's discuss in detail about the stages of continental drift. In 20th century, Alfred Wegener introduced the theory of continental drift to describe and explain the present arrangement of continents and ocean basins. He postulated a massive supercontinent which he called Pangaea, which existed some 220 million years ago, then breaking apart into several large sections, namely Laurasia and Gondwana land. These two blocks were separated by a long, shallow inland sea called Tethys Sea. He suggested that these sections moved away from each other. Let me briefly give you the explanation of movements of the Earth's crust. As you can see, the supercontinent is known as Pangaea. The superocean is known as Panthalsa. And Pangaea broke up into two large sections, Laurasia and Gondwana land, which we call northern portion as Laurasia and southern portion as Gondwana land, which was divided by a Tethys Sea. Now you can see the modern world. It took millions of years for the continents to reach its present shape and position on the globe. Even today, many of the continents are moving very slowly, pushing each other. Let's learn about the Earth's grid system. Latitudes. The Earth's grid system. Latitudes and longitudes together form the Earth's grid. Latitudes and longitudes. On a globe, a network of latitudes and longitude is drawn. This is called the grid. With the help of the grid, we can locate places and learn much about them. How hot or cold it would be there, in which direction should we go to reach it, and what time it would be there at any moment. You can see the northern hemisphere. Northern hemisphere continents are North America, Europe, Africa, Asia. Whereas the southern part of the southern hemisphere, the continents are South America, South Africa, Antarctica, and Australia. If you're moving towards the western hemisphere, you will find the western continents like North America, South America, some part of Antarctica, and some part of Africa you find. When you move towards the eastern hemisphere, you will find the eastern continents like Europe, Africa, Asia, Australia, and parts of Antarctica. Let's learn about latitudes. The horizontal circle that goes round the Earth exactly in the middle at equal distance from north and south poles is called the equator. Because it divides Earth into two equal halves, this circle is designated as 0-degree latitude. Following the way angles are designated in geometry, latitudes are expressed in degrees, minutes, and seconds. In many atlases, you will not find the minutes and seconds. Latitude comes from a Latin word, latitudo, means width. From the equator, going towards the poles are a series of parallel circles. Each circle is called a latitude. Latitude value ranges from 0-degree north, 0-degree equator, and 90-degree north to 90-degree south. There is no latitude less than 0-degree nor greater than 90-degree. All latitudes on either side gradually become smaller and smaller towards the poles. At the poles, 90-degree and 90-degree south are not circles, they are just points. There are 181 latitudinal lines. These latitudes are divided according to the sunlight falling on them. For example, equator is the largest latitudinal line. Here you will find the sunlight throughout the year. Tropic of Cancer, Tropic of Capricorn, Arctic Circle which is frozen throughout the year, Antarctic Circle which is also frozen throughout the year. So these latitudinal lines have been divided according to the sun shines on them, sunlight falling on them. Let's discuss about longitudes. Longitudes show us the length or height of a map. Longitudes are not full circles, they are semicircle, connecting poles to pole. Every longitude cuts across every latitude. The longitude that passes through the astronomical observatory at Greenwich, England, is called the 0-degree meridian, prime meridian, or Greenwich meridian. Several countries try to fix a longitude that passes through their own territory as the 0-degree longitude. There are 360 longitudinal lines, 0 to 180 degree east longitude, 0 to 180 degree western longitude. Longitude and the question of times. It takes 4 minutes for the sun's position to move 1 degree of longitude. As you can see, 0 degree to 15 degrees, when it was moving within 0 degree to 15 degrees, 15 degrees are there. There is a time gap of 15 degrees. So each degree of longitude consisted of 4 minutes. The world is divided into 24 time zones starting from the Greenwich meridian going east to west. The width of each time zone is 15 degrees. As you can see, 0 to 15 degrees, 15 degrees to 30 degrees, which is again a 15 degree, 30 degree to 45 degrees, and so on. So the width of each time zone is 15 degrees of longitude. The difference between one time zone and the next is 1 hour. So if you're moving from 1 degree to another degree, 1 hour difference you will get. From 1 degree to another degree, again you will find 1 more hour. So 2 degrees, 2 hours gap you will find, 3 longitudinal lines, 3 hours of time gap you will find. 60 minutes, 1 hour. Likewise, 0 to 15 degrees, 15 longitudes into 4 minutes per longitude is equals to 60 minutes. When you are moving from eastern side, 0 degree to 180 degree, if you are moving towards, you will find plus 4 minutes. That is 4 minutes will be added. It is called as east gain add. 0 to 180 degree east is called post meridian. And if you're moving from 0 degree to 180 degree west, you will find minus 4 minutes. That is west loss subtract. 0 to 180 degree west, called as anti-meridian. You can see here 0 to 15 degrees, the time gap. So 1 degree is equals to 4 minutes. So 4 minutes into 15 degrees is equals to 60 minutes. That makes an hour. Let's learn about longitude and the question of times. You can see the world standard time zone. Here you will find 0 degree as prime meridian or Greenwich meridian. So which is 12 noon, you can see 12 o'clock. And if we are moving 0 degree to another longitudinal line, that is 15 degree, the next longitudinal line you will find 1 hour is being added up. This is 12 o'clock, this is 1 o'clock. Another longitude, if you are moving towards, you will find another plus 2. That is 1 more hour. 1 hour plus another hour, 2 hours. 3 longitudinal lines, if you are moving, you will find plus 3. That is 3 hours. For example, if we compare 0 degree Greenwich meridian towards our country India, you will find 5 hours, 5.5 hours. So our country's standard time is 5.5 hours ahead than Greenwich Meridian. This is eastern side. If we are moving towards from 0 degree Greenwich Meridian, prime meridian towards eastern countries, if we are moving, you will find all plus every longitudinal line going on 9 longitudinal lines plus 9 hours. Likewise, if we are moving from 0 degree prime meridian towards the western side, you will find all minus 1. One longitudinal line minus 1. Here it is 12 p.m. Here you will find 11 a.m. Likewise, if you're moving towards the west, every longitudinal line if you cross, you will find minus 1 hour difference. See 1, 2, 3, 4, 5 longitudinal line minus 5 hours delay. So if you compare 0 degree meridian, that is 12 noon, to North America, that is Alaska, if we are comparing the time, then it will be 2 a.m. there. 2 anti-meridian, 2 a.m. Thanks for watching.